There are many things we can do to defend our web server, so let's look at some of the general recommendations. First of all, you want to have a separate secure server security segment. In other words, separate out your web server from other things. Your web hosting network should have, at the minimum, 3 segments. Now, segments are secure parts of your network. There will be the internet, there will be the DMZ, which is sort of like a secure public-facing area, and then there will be the private internal network. You put the web server in the DMZ. You isolate it from the internet, and you isolate it from the intranet. You, of course, need firewalls on either side of this DMZ. And DMZs are subject for Network Plus and other networking classes. Make sure you keep this thing patched and up to date. Keep the server, keep the application, all patched and up to date regularly. Review any documentation before applying a patch or a hotfix just to make sure it doesn't break anything. Update and apply as needed, and also on a schedule. But you put in the hotfixes, the quick security updates as they come out as needed. But I have to warn you, make sure that you can roll back in case it breaks something. Test those service packs and hotfixes in a non-production environment. A virtual machine is a great choice before you apply it to the production environment, just in case it breaks one of your web apps. The level of patching and hotfixes needs to be consistent across your machines, and especially if you have a web server that's on a domain controller. Now, that would just be an intranet, certainly not public-facing, no way. But if you on an intranet had like an all-in-one machine that's a domain controller and a little web server and a this and a that, you need to make sure that all the patches and hotfixes are consistent. On a regular basis, schedule server outages so you can make backup tapes or backups and emergency repair disks. And for heaven's sakes, if you back up, periodically test your restores. And make sure that you have a backout plan in place. In case you do something and it messes something up, you can roll back. This is where virtual machines are great, because you capture a snapshot and you roll back the snapshot if you have to. If you don't have virtual machines, then at least have a backup where you can roll backwards. And periodically upgrade your service packs. Don't get so far behind in your service packs that you've got all these wide gaping vulnerabilities. Recommendation, don't be more than 2 service packs behind. I don't mean the hot fixes or the little patches. I mean the major service packs. For the protocols, block on the firewall unnecessary ports and protocols. Harden the TCP/IP stack and apply the most recent software patches and system updates. Ensure that you're using secure authentication, TLS, SSH, and 2-factor authentication for remote admins. Make sure you're using that rather than just the clear text version of the protocol. Make sure you adequately secure all remote connections using tunneling and encryption. And I don't mean just remote desktop protocol. That's not good enough. Use like an IPsec, Cisco VPN, AnyConnect, or something that is IPsec based rather than just RDP based. And disable and or secure WebDAV. WebDAV is a feature that allows people to browse directories, which normally that's a bozo no-no in websites, but sometimes it's necessary. Get rid of any application extensions or modules that you don't need. Disable any unused default user accounts. If this is on IIS, on a Microsoft machine, make sure you've got proper NTFS permissions, and you put that in for anonymous users for whenever they have any access to the web root directory. Get rid of any unnecessary database users or stored procedures, and use the principle of least privilege for the database app. Make sure you use secure web and NTFS permissions and .NET Framework access control mechanisms. .NET Framework is what we use a lot to develop things on for Microsoft machines. Make sure you have strong password policies in place with auditing and alerts for failures of login. Run all processes with least privilege and least privileged accounts and least privileged service accounts whenever possible. And Microsoft and other vendors will have recommendations for that. Don't let everything be a domain admin. For files and directories, get rid of any of those unnecessary Java archive files, those jar files. Disable service directory listings. Use bytecode to eliminate configuration information that is sensitive. Get rid of non-web files. Do not map virtual directories between servers or over the network. Now, of course, this then works against your performance because very often a website will point to directories for like media to another server. So this now is security at direct odds with performance. Create resource mappings to disable service-specific file types. Like if nobody needs an XLSX, turn that off. Regularly monitor network service logs, database server logs, OS logs, and website access logs. Make sure that web apps or web files and scripts are in a separate partition, separate drive than the OS and the system files. And honestly, have this automated and just check it. Now, here's an example of brute forcing a directory. So here we are using the OWASP Dirbuster brute forcer. When you're doing security auditing and you're doing checking, there are plenty of directories in your website that there's no link to. The application just needs to know where to go. So a common auditing method for security of websites is to just take common directories that are typically found and then just send a whole bunch of requests to see which ones actually respond. So if we look here, we can see that this tool is testing for directories in the root. It's testing for files with a PHP extension. It's testing to see if there is a directory called info and if there's anything inside of it, as well as PHP files. It's testing for a directory called I and see if there's anything in that, or if there's something under info called store, etc., etc., etc. What you do is with these Dirbusters, basically, you provide a list of common directories that we expect typically, and then it just tries to make connections to those to see if it gets a positive response. Even if it's not allowed, you know that it's there. Defend against HTTP response splitting and web cache poisoning. We have already talked about response splitting, web cache poisoning. We've talked about response splitting in terms of a man-in-the-middle attack, and we've talked about it in terms of getting a server to send two responses, one of which, the legitimate one, is ignored, and the browser only sees the illegitimate one. So for server administrators, use the most recent web server software. Keep the OS and the web server updated and patched. Run vulnerability scanners regularly. For app developers, restrict web app access to unique IP addresses. Do not permit carriage returns and line feed characters. And if you're using HTTP 1.1, ensure compliance with RFC 2616. So web app developers should be looking this stuff up. By the way, go to OWASP.org. They'll teach you how to do this properly. If you have proxy servers, do not allow incoming TCP connections to be shared among clients. Have different TCP proxy connections for different virtual hosts. And correctly implement main request host headers. To defend against DNS hijacking, make sure that you only use an ICANN accredited registrar like GoDaddy and request them to set a registrar lock on the domain name so that people can't try to take it over. You can hide behind your registrar. You can hide behind GoDaddy so that you, the registrant, your account information is not viewed when people do a whois. Make sure that DNS hijacking is built into how you will respond to an incident. So consider DNS hijacking as a possible threat and build in response to it in your business continuity incident response planning. You need to monitor DNS server addresses and alert in case your domain name suddenly changes its IP. So there are automated tools and services you can use. Do not download any kind of audio or video codec. That's the thing that encodes and decodes, basically, so that these files can be smaller. Don't get any of these kinds of things from anything other than a trusted site. Ensure that you install and regularly update your antivirus, and for heaven's sakes, change default passwords, including on your router. So that is some general defense for your web server.